So this is going to be we've already talked about smoothing data a little bit.
We talked about that, and
yeah,
that
we
was
talked about the
it.
one in the green box. But there's a bunch of ways to smooth data. So I figure why not just exhaust all of the ways that I can think of that are commonly used to smooth out data streams. Now the boxes on the top here, these colored boxes, green, orange, yellow, pinkish, whatever. These are ones that are going to operate on like constant data streams. These are all connected to metros. So every 20 milliseconds you're getting a piece of data. Even if it's the same as the last piece of data, it's still a piece of data. So this is for like constant input streams, or continuous streams of data. So then down in blue here I have a different way to do it that are more for like non-continuous data. Like you get a number here, maybe a little bit later you get another number, and you want to smooth out between those two. Instead of jumping right from one number to another, you want to smooth it out a bit.
Right.
But let's start first up here at the top. So we already talked about the simple smoother. So I have a metro connected to a random 1000, and then I'm multiplying by 0.001. So I'm getting the 0 to 1 value, but it's a random number, so it's inherently noisy. It's just noise. It's actually just noise. We're running that value through the smoother so that you can see, and this is like a one pole low pass filter just on a data signal. It's weird and mysterious. I don't fully understand it, but anyway, it involves a feedback loop. But you send it a 0 to 1 value to tell it how strong that feedback loop should be. So 0 is 0 smoothing, 1 is 100% smoothing. But let's turn it all the way off and turn on the metro here. So you can see the data is just random. It's just pure noise. But when we start cranking up the smoothing, you can see it change character right away. It's still noisy, but it's not the same. Now if we start to really crank up the smoothing, it gets really effective above like 0.9. You can see it's just smoothing that data out. And if you keep going all the way up to like 0.992, it's really calm now.
That's craziness.
Yeah. And you can see some character in the data now if we just back off the smoothing a little bit. So this is my favorite one. I love this thing. I use it constantly. It's really computationally efficient. It doesn't cost anything really. I just use it constantly. Another way to do the same thing, actually with a little more flexibility, is this object called slide. Slide takes two arguments. There's a slide up and a slide down. So you can basically smooth separately for when the value is moving up versus when it's moving down.
Wow.
Which is kind of cool. So we turn on the random number generator just like before. And
these are new for me.
If we have no smoothing, it's just noise. And if we start increasing the slide amount, it's the same as what we were doing before with the one pole smoother. And you can really just make it as high as you want. Or, for instance, I'm going to turn it all the way back down. You can just slide up. So you can see, look what's happening. It's smoothing only the uppiness of it.
Right.
And so you get these weird little jaggies. I don't know, it's super weird. Super lovely, actually. Okay, there we go. Or you can smooth just the down. Or you can have some strange combo
Upsy downsies.
of uppy downy smoothing. See, this is like how little I understand about what's actually going on. I'm just calling it uppy downy smoothing.
Hey, you know more than I do. This is a new object for me, so.
But maybe I should use slide more instead of the smoother, because this is pretty cool. All right, so that's slide. Now, when you start translating your numbers into signals, then you have all the Msp signal operators you can use to smooth out data, which is kind of neat. So there's a signal operator or Msp object called ramp smooth. And that's very similar to slide, but it operates on a signal. So we'll turn on metro, and it's still going into the random number. It's still going to the point, multiplying by 0.001 in order to get a number that's going to vary between 0 and 1. But I'm going into this object called sig. Any number that you send, when you send a number into sig, it turns it into a signal. So if I send a 5 into sig, it's going to turn it into a Msp signal that just pumps out a 5 44,000 times per second at sample rate, which is cool because then it becomes an audio signal that you can use all the audio objects to manipulate that number, and then you can translate it back into a regular number that you can use using snapshot or something. Oh, like for what we have right here, snapshot. So sometimes you want to dip into the signal domain just to manipulate your data, and then dip back into the numbers domain.
Right.
So let's turn this on.
Well, this also shows us
and
that
also your microphone has to be on. That's a downside. But.
This also shows that you could take, signal data and, yeah.
Right. Sometimes your sensors are signals. Okay, so we have, now it's ramping up and down, but it's doing it in samples. So Slide was doing it in some other format that I don't quite know. Now it's doing it in samples. So your numbers have to be pretty big, actually really big. So 44,000 samples per second. So if you want to smooth the data over the course of like half a second here, then we have 23,000 samples, and it's doing a pretty good job. And you can also do it like before, where you have different smoothing amounts on the upside than you do on the downside. So let's see if we can get those little jaggies to happen here like they did before. Oh yeah, they're starting to. Whoop! Oh no, I went negative. Okay, so yeah, same exact behavior as with Slide, except we're in the signal domain now using ramp smooth. So there's that. And then there is an object called OnePole. OnePole does the same thing that Smoother does. It does a one-pole low-pass filter on the signal, and you just specify the cutoff frequency in hertz in cycles per second. So we turn on our data, we get this noisy data, and if I have a high frequency cutoff, then it's like nothing's happening to the data. But if I lower the frequency, this basically says anything below 200 hertz is going to be cut out. Sorry, anything above 200 hertz is going to be cut out. Mm-hmm. So if I start lowering my frequency, only the low frequency data is going to pass, which is the same as smoothing. So when I start to get really low signals here, you start to see the data smooth out, just like we were doing with Smoother.
It's like magic.
Yeah. Okay, so that is continuous data. What if you have non-continuous data? So this is just, you can use this line object here just to ramp between values. So I give it a 5, let's see, I'll type a 1 in here, and it's going to ramp down to 1. I type in a 9 here, and it's going to ramp up to 9. Now it just does a linear ramp, so it ramps in a linear fashion from your start point to your new point. And it does it over the course of 1,000 milliseconds because my message here has $1 space 1,000. If I were to change this to like, I don't know, 5,000, then it's going to be a 5-second ramp from 9. Let's go back down to 3. Now it's going to ramp down to 3 in 5 seconds. So that's all that does. And here's another abstraction here. So like here I have 1, 5, 10, back down to 1, 5, 1. So when you need to just smooth between two numbers, but they're not continuously coming in. They only come in sporadically. You can also connect the slider up and sort of smooth out the motion.
I've seen this used a lot in volume control when you want to control like how quickly the gain goes up.
Yeah, sometimes you don't want the gain to jump.
Right.
There's a signal version of line too, which people use for that.
Right.
So line tilde does this exact same thing, but with signals.
Right.
So there's the smoothing tutorial. It's amazing to me how often a little bit of smoothing of your data stream can make or break a whole project. Sometimes students come to me and they're like, why is this not working right? And we just add a little bit of smoothing to one thing and the whole project suddenly works much better. It's really neat.
A lot more fluid.
Yeah. All right.